All right, we're looking at section 311 related rates, and our first question is like a vocabulary property. It says that two opposite sides of a rectangle increase in length. How must the opposite two sides change if we want the area to stay the same? So if one side is increasing and we want the area to be the same, the other one has to decrease, so that when we multiply length times width, we get the same number. And so the one that says that, A, if two opposite sides increase, the other two opposite sides decrease in length if the area of the rectangle is to remain constant. So A is the one we're looking for. And then number two, it just says the sides of a square increase at a rate of 4 meters per second. We have two parts. What is the rate? The area of the square is changing when the sides are 25 meters long, and at what rate is the area of the square changing when the sides are 25 meters long? So 15 and 25. All right, so first we need to know formula for area of a square. Area of a square, and it tells us A, we're going to use the length of a square side S. So A is going to be equal to S times S, or S squared. In the beginning, they tell us the side is increasing at a rate. So whenever they give you a rate, a side, they're giving us how that's increasing with respect to time. So it says meters per second. So we are going to write ds, the rate at which the side is increasing with respect to time, dt, is given by 4 meters per second. All right, now we want to write an equation relating the area of a square A to the side of the square S. So that is just going to be A equals S squared. And then we're going to differentiate both sides with respect to t. Okay. So when we do the derivative of a, it's 1 and then dA dt. So we get dA dt. And then derivative of s squared is 2s. And then the derivative of s is ds dt. You want to treat that like a chain rule. So derivative of the outside and then times the derivative of the inside. So here's our derivative. All right, now we're going to find the area of the square is changing at a rate of, so now we're going to plug in what we're given. So here, 2, it said when S is 15 meters long, so S is 15 in part A. And then ds dt is 4 meters per second. So you multiply meters and meters, you get meters squared. 30 times 4 is 120. So we're looking at 120 meters squared per second, and that matches the dimensions of area. It should be square units. All right, part B, area is changing at a rate of blank when the square is 25 meters long. All right, so same exact formula. This time we're going to plug in 25. And we're still increasing at a rate of 4 meters per second. So multiplying all that, 4 times 25, 100, 100 times 2 is 200. So we get 200 meters squared per second.